Myself, Dr. K. Viswanath Allamraju, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today we are going to study the straight line motion mechanisms. There are various types of straight line motion mechanisms. Here we are going to study in this session the straight line motion mechanisms are. One of the mechanism is pantograph. The pantograph is a 4-bar mechanism and it is a 4-bar linkage. The function of this mechanism or pantograph is in order to copy the diagrams or copy the sketches or copy the maps. If you want to reduce the scale in reduction scale or minimum scale, a reduction scale or maximizing larger scale, if you want to draw or if you want to draw the same replica, if you want to draw the same figures either in reduction scale or in larger scale, we will use this mechanism. So let me read. A pantograph is a 4-bar linkage used to produce paths exactly similar to ones traced out by a point on the linkage. So it consists of 4-bar linkage. It is a 4-bar mechanism. Okay, either you want to draw a straight lines or a curved ones, you can. Now, this 4-bar this pantograph consists of where the links, the fixed link is O, that is O is the fixed link, and this OC is one of the link. OC is the link 1, this is link 2, and it is link 3, and it is link 4. That's why it is known as a 4-bar linkage. There are various points on this pantograph. The various points are O, D, C, B, and A. And also there are another points are there. The points are P, Q, and R. This P, Q, R we are going to prove mathematically by using the concepts of geometry. The path traced by this mechanism gives a straight line by considering various points on the mechanism. Now, here we understand there are various things are there. Points are A, B, C, D. This A, B, C, D formed as a parallelogram. These 4 links are arranged in such a way that this ABCD formed as a parallelogram. Now, thus, when it is parallelogram, immediately length of link AB equal to DC. That AB equal to DC is the opposite side, and BC equal to AD. This BC equal to AD. If some point O on one of the links, it is some point O, is O on one of the links is made fixed, the O remains fixed, and the other points, what are the other points are? P, Q, and R. This P, Q, R on other links are located in such a way that OP QR becomes a straight line. The path traced by, again, O is the point on one of the link. This PQR are the points on other links. In such a way that the path traced, the location of this OPQR is a straight line. Now, here, now one more point is that this OPQR and also this point P, Q, and R always move parallel and also similar to each other. It will move parallel. Now understand here, the pantograph is this much portion. What about the portion below? This portion is the another motion. If pantograph moves in another position, this is initial position and it is final another position. This is the first position and it is the second position. Suppose if the pantograph having certain motion among the links, then what will happen? The O remains fixed. It doesn't change. Whereas the points P, Q and R becomes P dash, Q dash and R dash. And the parallelogram points are there. A, B, C, D becomes A dash, B dash, C dash and D dash. Okay. Their motions will be proportional to their distances from the fixed point. Their distances from the fixed point. What is their motions are? Here initial position motion is OP. After traveling it becomes OP dash. After moving it is OQ, it becomes OQ dash. It is OR initial position, it becomes OR dash. But the ratio among themselves, among initial position, that is OP, OQ, OR, and second position OP dash, OQ dash, OR dash are remain same. When the ratios are remains the same, that means their path remains a straight line. There is no effect in the output. Suppose it is a simple example of like in mathematics. A by B equal to C by D. If you multiply both the numerator and denominator on both LHS and RHS multiplied by any factor, I am taking multiplying with factor 2. Is there any change ratio? 2A by 2B ratio is the same as A by B and equal to C by D ratio. It doesn't change. That is the same concept we are going to use to understand the working principle of pantograph. We have to prove, as I told you, mathematically, based on the concepts of geometry concepts, fundamentals of geometry, let OPQR lie on links. Where the links are, O, P, Q and R lies on the link. And the links, where are they? O lies on link CD, P lies on link AD, Q lies on link AB, and R lies on link BC. Now, ABCD is assumed as the initial position. It is initial assumed position, which is shown in figure. Now, let the linkage be moved another position. Please understand, pantograph is the portion of this portion O, D, C, B, R, A, P, Q, R. This portion is the only pantograph. Okay, this portion, which portion? This much portion is the only pantograph portion. After this, the initial position. When it moves another position, then don't think both considerations are pantograph completely. No. Okay, initial position and second position. Now, let the linkage be moved to another position so that A moves to A dash, B moves to B dash, and so on. C moves to C dash, D moves to D dash, and P moves to P dash, Q moves to Q dash, and R moves to R dash. In triangle ODP, there are two triangles, ODP, and the same triangle, if you consider another triangle, that is OCR. There are two triangles are there. This is ODP and it is OCR. ODP and OCR. OPR or OPQR or OPR on a straight line. Why we consider only OPR? Because we are considering the triangles of OP and OR sides. This OP, ODP and OCR. Okay. So we're considering ODP and OCR. OPR lies on a straight line. Thus, OP by OR coincides because it is on a diagonal if you consider it on a straight line. Now the angle between DOP equal to angle COR. Angle DOP, angle COR, that means angle remains same. Similarly, it is triangles are by considering now at the angle D position, angle ODP equal to angle OCR. These are the same triangle. These are the same angle remains same. Now the triangles are similar. Thus, when triangles are similar, when it satisfies these conditions, then we'll call it as the triangles are similar. Now, if triangles are similar, and what will happen now? The ratio of the diagonals. What is that? If you can take any one side, OD by OC equal to OP by OR. Or then, if you consider this side, OD by OC equal to this side is over OC side. Then you consider this side, then OP by OR. Then you make it this side base, that is PD by RC or CR. So that is the concept. That is the for first position. Now make it apply for second position, new position. Now we will make it. What is that? Make it that remains the length of the links or remains constant. That's why A dash B dash, even though it goes to new position, A dash B dash equal to AB and DC that equal to DC equal to D dash C dash. Similarly, B dash C dash equal to BC that equal to AD equal to A dash D dash. Now, by parallelogram, now we are considering the second position parallelogram, that is A dash, B dash, C dash, D dash is again a parallelogram. Same apply the relationship. What is the relation? Again, new positions. OD dash by, now which are the triangles are similar triangles? The similar triangles are, which are we are considering, OD dash P dash from triangles. OD dash P dash and same apply. OC dash R dash. We are considering. Among OD dash P dash and OC dash R dash, what will happen? Okay. Same apply the concept of the ratios. The ratios are OD dash by OC dash equal to OP dash by OR dash equal to D dash P dash by C dash R dash. Thus we can make it C dash R dash. Now that is T dash P dash by C dash R dash. Now this angle OD dash P dash equal to angle OD dash P dash equal to angle OC dash R dash. Now these triangles are similar. Yes, the same position, initial position we have applied. The concept to initial position, it is same as in the second position, same concept. Now, as OPR on a straight line, in the new position also, because it is similar triangles, the triangles are similar, the positions OP dash R dash are also on a straight line. It follows exactly. Now, OP by OR equal to, from first position, OP by OR equal to OD by OC. You apply for second position, that OP by OR means that equal to OD by OC means OD dash by OC dash, that is same ratio as OP dash by OR dash. So what we are talking is that is very simple. No need to go for second position. Why we are using for second position is very simple. The concept, this pantograph is finished here, pantograph concept. The triangles are the same, the triangles are similar. So, when the triangles are similar triangles, if you give any position or any position from another position also, the ratio remains the same. When the ratio remains the same, the distances remain same. When the distances remain same, when the points in the initial position, because of the ratios are same, in the final position also, it remains the same. That is the concept of pantograph. Let's check out how the pantograph functions. We'll understand better. In this diagram, you can see how the pantograph is working. Even though this picture is the source, is mentioned the source link of this animation. Okay, it is copyrighted one, but we have taken the request and we are quoting source. Now this is the position, initial position. How if we attach, where is the attachment of this position is small, that position is at point A. Now what is the next position? What is the final position? This final position is capital R dash. This is R and A. You attach pencil or anything, any instrument to draw, then what will happen? The motion of, if you want larger, you keep the diagram small focus, you draw motion. The motion is proportional to it comes larger scale. So thus pantograph, what is this position? This position is O. Okay, it is on D. It is C. You can understand it is A and it is B. And it is R. Enter position is R. So how it moves? In order to do the replica from large scale to small scale or small scale to larger scale, this mechanism is used. Okay, that is the concept of pantograph. Now, final conclusion in this: how can we know that this is a straight line? Finally, that ratios are remain same both in the initial position and in the final position. So the linkage is the ratio of the distances P and R. The ratio of the distances P and R from the fixed point remains the same, or the 2 points are displaced proportional to their distances from the fixed point. The distances from the fixed point. This will be true for all positions of the motion of the links. The P and R will trace exactly similar paths. So it can also be proved that P and Q trace similar paths. So P and Q, as A and R traces similar path, P and Q also traces similar paths. Thus we can understand that P, Q and R traces a straight path when the linkage is given in motion. When the linkage is given motion, it traces a path. But point is that there are two things are there. The pantograph is useful to draw the larger scale to small or smaller scale to larger scale. But one more thing is that the points on a pantograph, we assume the way assumed here, P, Q and R, O, P, Q and R, their path is always, their motion is always, if you join, is a straight line. Okay, it is also one of the mechanism. Next, straight line motion. Okay, mechanism is that very important is the Peace-Layer mechanism. How many links are there in this Peace-Layer mechanism? This Peace-Layer mechanism is a 8-link mechanism. Okay, if you understand the concept of eye centers, how many eye centers for 8-link mechanism? Again, 8 into 7 by 2. That is 28 eye centers. So, 14, 78. That is 14 eye centers for Peace-Layer mechanism. So, this Peace-Layer mechanism gives whatever input motion may be, the output motion gives the path traced by a point is a straight line. What is the output point here? The P. P is the output point here. How many links are there? 8 links are there. So, to understand the physical motion of a Peace-Layer mechanism, then we'll come to understand mathematically how to prove the path traced by a point and a Peace-Layer mechanism is a straight line. Let us see here. Whatever motion may be here, and the path traced by, this is the point P, link. The point P is tracing is a straight line. Okay, this is a straight line. How it is tracing? Whatever motion may be, but the mechanism is arranged in such a way that the path traced by point P is a straight line. Now coming to the point of how to here. Yes, as we have studied, as we know that P-layer mechanism is a 8 links mechanism. Consists of 8 links such that in order to get the straight path of the point P, how to design the P-layer mechanism, what is the geometry. So we have to follow the certain rules such a way that we can get the motion of the point P is a straight line. That is OA equal to OQ. OA, this OA link, length of the link OA equal to OQ should be same. Next, length of the links AB equal to AC. Where is the AB? This is the AB and also it is AC. AB equal to AC. What are the next points? The next links are, this is the jump, what is the rhombus? How to follow parallelogram? Now rhombus here, all that is like a square, all the sides are equal. That is BP equal to BQ, that equal to PC, that equal to QC. So this portion all are equal sides. And what should be fixed in order to get OA should be fixed. OA is the fixed link, and which one? OQ. This OQ starts oscillating. When OQ starts oscillating, the link traced by the point, the path traced by P gives a straight line. So it can be proved that as the link OQ moves around O and also P. Okay. OQ moves around O. Okay. OQ moves around O means this OQ fixed point is O. It moves, this OQ moves like that about O, but P gives the path a straight line. P moves in a straight line perpendicular to OA. That means it is a straight line that is perpendicular to OA. So in this, one more important is that all joints are pin jointed. Okay, it is not welded jointed or permanent joints and all joints are pin jointed so that it can be moved easily. Okay, that is the what concept of this P-layer mechanism. Now this is the description, this portion is the description of P-layer mechanism. Next step is that, what is the second portion? Second part is that how can we know how to justify the path traced by a point P is a straight line. Okay, let us begin our geometric concepts. Very important. Since what are the points are here, as we have studied, this points is here, the point there are BP CQ or CP BQ. CP BQ is a rhombus. All sides are equal. Next, QP. This QP always, this QP is there. This QP line bisects which portion? CB line or BQC. It bisects BQC. When it bisects this portion BQC, what happen? Angle 1 equal to angle 2. Similarly, angle 3 equal to angle 4. Okay, now when it is bisecting, no, bisect means equal will come. What is the bisection? Equally, secting equally, bisecting. Suppose total angle is 60 degree. By bisecting this line, this portion becomes 30 and this portion becomes 30. Bisection means equal section, equally dividing. That is the meaning of bisection. Now, this angle 1 and angle 2 remains same for all positions. Then only straight line comes. Otherwise, if it is changing, the straight line doesn't happen. Okay, it becomes curved line. Now, angle 1 and angle 2 remain same. Why? This QP is always bisecting the triangle BQC, doesn't change it. Okay, that's why the path traced by a point P is a straight line. That's it over. With that justification, you can make it. But you want to explain in detail further what will happen. In all, also triangles, another triangles you are taking. The triangles coming top portion, rhombus portion is over. This rhombus portion is over. Now we are coming to the portion down, this portion. Now the triangles, what are the triangles are? AQC. Where is AQ? This is AQC. This portion is equal to the triangles AQB. Same, both are equal portion. The triangle AQC equal to AQB. Now which one is common here? AQ is the common. Now in that what will happen? AC equal to this AC equal to AB and QC, this QC equal to QC. Where is the QC? When it is AC equal to AB, this QC equal to QB. Then only equal, no, it is equal portion. Suppose, very simple, if anything, how it is, this, there are two triangles are there. AQ is bisecting the portion, no, this is one. Second portion is, this is another portion. Now, AC equal to AB. Next, if AC equal to AB, then QC equal to QB. So, these triangles are congruent in all positions. Then, the angle, this side angle is same as this portion angle. That is, remains the same. That is, angle 3 equal to angle 4. For a rhombus, angle 1 equal to angle 2 for all positions. Now, adding this angle 1 and angle 2, these two, that means angle 1 plus angle 3 equal to angle 2 plus angle 4. Then what is the angle 1 plus angle 3? This angle 1 plus angle 3, consider it, is equal to 180 degree. And angle 2 plus angle 4 is another 180 degree. Now all the angles total, it becomes 360 degree. That's why here it is. Angle 1 plus, angle 2 plus, angle 3 plus, angle 4 equal to 360 degree. Then each portion is out. Angle 1 plus angle 3 equal to 180. Angle 2 plus angle 4 equal to 180. Now, very simple. When all the angles are equal, the path traced by point P. What is that point P? Is a straight line. How can it become a straight line? This AQP is a straight line. The path traced by A, that's why AQP is on a straight line. Then the path traced by point P is a straight line. That is another way of. Still further we want going to explain. You can end up anything anywhere. When similar triangles are there, the ratios remains the same. Okay, when the ratios remains the same, the distances on the points, whatever position may be, it remains the same. So definitely, the path traced by a point P is a straight line. Now, another explanation. Now we are coming to first portion. There are three portions over. Number one, description. Next portion is about rhombus, top level. Third portion is bottom level. Now we are coming to the portion level where it is the remaining, that is the output portion. That is P portion. Now PP dash is a perpendicular or straight line. That is OA is extended. Suppose. Now again another triangle is there. That is APP dash. That is another triangle. Now we made another similar triangle. That is AQQ dash. Yes. AQQ dash and APP dash are similar triangles. Then angle 5 is same. Angle 5 is common to both the triangles. The angle 5 is common to both the triangles. What are the triangles are here? Yes, and it is. What is the triangle? APP dash and another triangle AQQ dash. Now, the ratio of, again the ratio of similar triangles remain same. AQ by AP dash, AQ by AP dash, because it is 90 degree, equal to AQ dash by AP. Now, if you make it multiply the diagonals, AQ by AP dash into AQ dash equal to AQ into AP. Now what is that AQ? Again, coming back here. This AQ equal to, this is the portion up to here. AQ equal to AR minus QR. Then AP equal to AR plus RP. Now this RP is equal to, both the remains, RP equal to RQ. Now A plus B into A minus B, A square minus B square. This AR minus RQ into AR plus RQ. That is AR square minus RQ square. Further we are simplifying that. This AR equal to, again, what is that AR equal to? AR equal to AC minus CR. Okay? AR, what is that AR? This AR square, again another Pythagoras theorem. AR square equal to what? AC square minus CR square. Next, RQ square. Where is that RQ? This is RQ square. This another triangle is there. RQ square equal to QC square minus CR square. Now finally, AP dash equal to AC square minus CQ square. AC square. Make it the CR square get cancelled. Simplification. After simplification, then AC square minus CQ square by this AQ. Now AC is a constant. What is that? AC is constant. The length of AC is a constant. Length of CQ. Where is that CQ? This CQ is a constant. And AQ dash, that is a new position. Okay? That is AQ dash is here. This AQ dash remains constant. Now total, the path traced by AP dash remains constant. So all are constants. Then you can understand that the path traced by a point P is a straight line. So now PP dash, that means what? If it is a constant, means what? The path traced by PP dash is always normal. It is normal means perpendicular line to the horizontal line. That means it is a straight line. That's why P-layer mechanism is a exact straight line motion mechanism. It is not approximate straight line motion mechanism. Why? The path traced by PP dash is perpendicular to OAP or OP dash. Okay. Now, that is the concept of, these are the two mechanisms we have studied. Number one, pantograph, and number two, P-layer mechanism. Many people understand it's so complicated. It's very simple to understand it. Again, I am explaining you in a summarize in 3 steps. First, draw the P-layer mechanism. Okay. After drawing the P-layer mechanism, very important. This P-layer mechanism, don't worry about while drawing this ellipses or horizontal lines, all the lines. P-layer mechanism is so simple that is a 8-link mechanism. What is that 8-link? Very simple. In this you understand animation. It is so simple that there is one rhombus is there on the top and bottom join and another link is joined. That's it over. Then in order to prove mathematically the path traced by a point, output point is a straight line, we marked all the dotted lines and curved lines, etc. But this is a P-layer mechanism. So simple. But after that, what to do? You explain at the rhombus portion, top portion. This is the rhombus portion, and bottom portion, it is. How it is equal? What we are doing? The third step is, okay, the third step, this is bisecting. AQ is bisecting, okay, the triangle. Also, this QP or this QP is bisecting QBC. If it is bisecting, means equal angles will be there. What are the equal angles? Are there inside? Angle 1, angle 2. And this AQ is dividing the portion exactly. This AQC equal to AQB. That's why angle 3 equal to angle 4. So angle 1 and 3 summation. Why it is like a straight line? No, it is 180 degree. 2 plus 4, it is another 180 degree. So 180 plus 180, 360 degree. Now, after the portion is explanation, next final portion is PP dash. PP dash is drawing a perpendicular line to AP dash. Then immediately we want to talk PP dash connected to where? Which line? PP dash is P is connected to A and bottom P dash is connected to A. Again, we have to prove that by using similar triangles concept, as you have explained in Pantograph also. That further what to do? Join Q with Q dash, that is the extension line. There you use similarity concept, similar triangles concepts. The ratio remains the same. If you understand thoroughly, you can still simplify this explanation of P-slave mechanism. But many books explain so complicated, the moment you look into the solution of this P-slave mechanism, immediately you will be disgusted or disinterest comes to understand this P-slave mechanism. It's very simple. Alright? Thank you.
Like, share and subscribe. Hit the bell icon for more updates.